This meeting is being recorded.
All right, thank you everyone, and welcome to our last mini workshop on media understanding of this spring semester. We've been jointly hosting these workshops between USC's Center for Computational Media Intelligence and the Muse team at Google. So for this talk, I'm really happy and honored to introduce Vinod, who'll be speaking on NLP and society, undesirable societal biases as barriers to those in the margins. So really interested to hear what you have to say about this today, Vinod. Vinod Kumar Prabhakaran is a senior research scientist at Google working on issues around ethics, fairness, and transparency in machine learning and natural language processing. Prior to Google, he was a postdoctoral researcher at Stanford University and obtained his PhD in computer science from Columbia University. His prior research focused on building scalable ways using NLP to identify and address large-scale societal issues, such as racial disparities in policing, workplace incivility, and online abuse. I've had the pleasure of knowing Vinod and collaborating with him in various capacities over the last several years. And I'm really, really excited to hear what you have to say. And thank you so much for volunteering to speak today and share this research with this group. So I'll hand it over to you now, Vinod.
Thank you so much, Cree, and thanks for the invitation. I'm excited to be speaking here today. I have attended like some of the talks in this series, and like this is such a fantastic lineup. So I'm thrilled to be in that set of people to be invited here. I identify as a computational social scientist, like disciplinary wise, who work at the intersection of AI and society, with a focus on language, social linguistics, and computational processing of language or natural language processing. As Cree mentioned, I work as a senior research scientist at Google Research in the Responsible AI and Human-Centered Technologies organization, where I look at issues around fairness, ethics, and transparency in AI systems, with a focus on NLP. However, prior to coming to Google, like as I said, like I used to use computational techniques to analyze large amounts of data, to understand social disparities in society. That work is still something that like is ongoing. And today I will be talking more from like fairness and ethics and biases in NLP or machine learning models kind of perspective, but it is relevant to the computational social science work as well, because increasingly computational social sciences use many of these AI techniques, NLP techniques, to do large-scale analysis to gain insights about society. So if those measuring devices, like those techniques that you're using themselves are biased, then you might actually be introducing systematic bias into your analysis. So that's one reason. So even though my talk is currently framed in terms of like how does a product or a technology affect like an end user or like communities, from a science perspective, from a scientist perspective, like using this as a tool, you could imagine like many of these biases that I talk about would also have implications for sort of like scientific insights that we can gain from them. So I'll try to sort of like call that out, like whenever that sort of like insights or that point emerges. But I do want to just like set that stage first. So as I mentioned, today's talk, it's titled NLP and Society, Undesirable Societal Biases as Barriers to Those in the Margins. Let me start with like one of the fundamental questions when it comes to machine learning based applications in general and NLP in particular. And this is something that people who work actively on things like media understanding and computational social sciences in general are also probably familiar with. This is the question, like a lot of NLP techniques ask, is how can computers learn from data? And this question forms the basis of a lot of modern NLP applications, and especially powerful language technologies such as word embeddings or contextual embeddings. If you've worked with like more recent NLP approaches, you might have heard of things like BERT or GPT-2 and so on. All these techniques aim to sort of learn meanings of words based on where they occur in data, and use that knowledge, use that representation that it learns from data to do more useful tasks downstream, such as machine translation or sentiment analysis and so on. But an important question to ask here is data a reliable, or data that we usually use to train these models, a reliable representation of the world we want to model? So for this, I'll start with a quick exercise. So if you have not seen these slides in the past, please unmute yourself and volunteer an answer. What do you see in this slide? Anyone?
Dole bananas.
Doll bananas, great. Any other answers?
Yellow.
Oh, Kamal. Okay, usually people don't say that. People usually say bananas. In the past, when I have asked this question, people say bananas, stickers, doll bananas, bananas at a store, bananas on shelves, bunches of bananas. But people, well, Kamal, your people too, but usually people don't come up with the answer yellow bananas. But if you're showing something, an image like this, you're more likely to get the answer green bananas or unripe bananas. And this is like a documented phenomenon. This is an example of what is called a prototype theory, an instance of prototype theory, where it's yellow is usually prototypical of bananas for most parts of the world. And that's why you don't usually call out the yellowness of the bananas. But I also see that Kamal said yellow rather than yellow bananas. So it's just like, what you're seeing there. But this is not something that happens just in the case of bananas. This happens in many other contexts too. For instance, we're more likely to call out the gender of a doctor when we are referring to a female doctor. In most cases, in the case of male doctors, people often do not specify the gender, since oftentimes, or for large majority of society, male gender is sort of prototypically associated for the doctor occupation, or stereotypically associated to the doctor occupation. This can also be seen using a simple web search. For instance, this is screenshots from like a few years ago. The actual numbers may have changed now, but when I took these screenshots, female doctor is a term that occurs more than twice as often as male doctor in articles indexed by Google. This prototypical association is also documented in a large-scale sort of like social science study conducted in Boston University in 2014. And I believe there have been like more follow-up work in that space as well. So this is an instance of human reporting bias. The frequency with which people write about actions, outcomes, and properties is not really a reflection of the degree to which a property is characteristic of the class of individuals. So when we try to build machine learning algorithms or NLP models to sort of learn meanings of words based on what's in data, it only captures these sort of like biased view of like what is captured in data that may not be really characteristic of the properties of many of the concepts that is present in data, in language data. So going back to the question of, is data a reliable representation of the world you want to model? Let's look at some more examples. Most web-based data also suffer from huge gender bias, along with many other kinds of biases in terms of who authors them. So this is like selection bias, right? So men are overrepresented in web-based articles, Twitter conversations, as well as in Wikipedia. Around 80% or so of Wikipedia editors identify as male by a study that was done a few years ago. And there's also a lot of NLP and machine learning technologies relies on label data. And in the last decade, we have seen crowdsourced labeling, crowdsourced annotations using platforms such as Mechanical Turk and Cloudflower has become sort of like mainstream ways of collecting data annotations. And this is sort of like a global representation or global sort of snapshot of at one point in time of like Mechanical Turk workers. So as you can see, there are specific hubs in the world where these annotators are coming from. And that could mean that such biases or such representational disparities in annotator pools may result in differences in cultural competencies and value systems that they bring in their annotation. So in this case, this is an example from an annotated data where people have labeled images with certain labels. The first two images were labeled with, all three images are images of wedding ceremony or right after wedding ceremony, whereas the first two images were labeled with ceremony, wedding, bride, groom, and so on. The last image was labeled as person or people, which probably comes from the fact that the annotators did not have the cultural exposure or knowledge to perceive this as like a wedding picture, right? And this might be happening in various other ways as well. So going back to the question of, is data a reliable representation of the world you want to model? Probably not. Now, why does this matter? In one of the early studies in NLP on this topic, Bolog-Bassi et al. Showed how the underlying representations of meaning, also called word embeddings, that form the core of many NLP systems, reflect social disparities and stereotypes, for instance, around gender. They found that these word embeddings or meaning representations, as they're often called, these representations have meanings such as man. The relationship between the word man and computer programmer is similar to the relationship between woman and homemaker, these words. That, as you can imagine, these are not based on like sort of like the sort of representational disparities that I talked so far about, but this is more probably some stereotype or even like societal disparities in occupation. But regardless, this sort of like these associations are learned by these models as meaning of these words, right? And that might have implications for those who are using these models for downstream use cases or social science analysis. And it also, in addition to the representational biases and disparities, it also has issues in terms of downstream sort of allocational decision making, right? In a couple of years ago, or a few years ago, Amazon's hiring tool was shown to be penalizing resumes that had the word women's, an association that puts female job applicants at a disadvantage, since that word is very likely referring to things like women's soccer team or women's tennis and so on. This is an instance where these biases, those stereotypical biases, or just coincidental biases, undesirable biases, result in affecting those at the margins, or like those who are marginalized in certain situations. Another example is a toxicity classifier, which, as some of you may be familiar with, there are a lot of NLP tools currently at use by various platforms to perform online content moderation. So when people engage in online social media to ensure safety and to keep social media more safe and welcoming to people to interact. But although this week has seen a lot of public debate around the issues around free speech and content moderation. We'll see where that lands. But regardless of whether a particular platform decides to continue doing that or not, there are a lot of platforms who want to do content moderation to make sure that their platforms are safe for welcoming for people to engage in meaningful discussion. Perspective API, which is a tool that Jigsaw, which is a Google sister company, has put together, is used by various platforms for doing this in various ways. It's not just about like banning content, but rather flagging content for human review, for instance. So it's used in very different ways. But online content moderation is a instance where NLP is or as an application where NLP is like significantly used in recent years. And it was shown that a naively trained model, NLP model, has strong unintended biases towards certain identity terms, such as LGBTQ terms and certain religious terms. For instance, this was a work from 2018. Again, the Jigsaw team themselves did this work and since then have addressed or mitigated some of these biases. So they found that the sentences such as the gay and lesbian film festival starts today had a toxicity score of 0.82 on a scale of 0 to 1, which is a very high score, as you can see. So these are probably biases come from the fact that the terms gay and lesbian is often used in social media in negative or derogatory terms, like saying like things like, oh, you're so gay, or that's so gay, and so on. And that is only meaning that the model has learned, or that is the predominant meaning that the model has learned for these words, and resulted in like the terms such as gay and lesbian getting penalized and being removed or being flagged as toxic. So before I go further, I want to just like add a word here. I will be using NLP-based abusive language detection or content moderation. For instance, this includes toxicity classification, hate speech identification, and so on, as a running example throughout this talk. No, not all of them are about Jigsaw's Perspective API, but most of the work I will now be presenting is on fairness failures in the task of abusive language detection. And because I'll be using this, I want to sort of like start by setting sort of some sort of common or shared understanding of what I mean by toxicity. I will be using the definition as put forth by Jigsaw team for what the definition that they used in their work, which is toxicity or a comment is toxic if it is a rude, disrespectful, or unreasonable comment that is likely to make you leave a discussion. Now, I want to note that this is not the only way to think about toxicity or online toxicity. There are many other definitions people have come up with. People have critiqued this definition. And some of it is coming from the fact that this is defined from the perspective of platform. Whereas like if you are, activist organization, or if you're a nonprofit working with activists on human rights on online spaces or something, you might come up with a completely different definition of like what it means to be toxic in an online space. So this is defined from a platform perspective for obvious reasons. This was like a tool made for platforms. But so toxicity is not like just like one single thing like that can be defined very differently. And I'll touch upon like some of that like towards the end. I'll come back to this point again in the end, but I wanted to say that this is a contested definition. But I wanted to put that out there before I use that throughout the talk. So now to give a little bit more structure to the talk, I will be using this sort of like slide for describing some of the kind of anchor points where my work that I'll be presenting will be addressing. So to set the stage, most recent machine learning models use a neural network based architecture that automatically learns the concept you're trying to teach it by looking at patterns in data and updating the weights between those neurons or layers according to how those patterns are associated with the concept that you're learning or modeling. Here I've shown just a small two-layer network, but these models nowadays goes up to like billions of parameters. So these are just to show where or which part of the ML pipeline I'm talking about. I'll start by looking at biases in predictions. So this is an example in like biases in predictions that I talked about in toxicity classification, right? And in similar vein, in 2019, our team looked at what sort of biases exist in these models around specific people, because these people are likely mentioned in data a lot, and what has the models learned about them? Turns out that just by changing the name from Katy Perry to Taylor Swift, a sentence can turn from or being labeled as non-toxic to non-toxic. Sorry, toxic to non-toxic if you're using like a threshold of like arbitrary threshold of like 0.75. And this is, an important. This could be super relevant for social science analysis as well. If you're doing some analysis around like certain individuals, certain politicians maybe, or if you're doing analysis on products or how people believe or think about products or how they talk about products online, these kind of biases can be a problem if the model that you're using to analyze large amounts of data itself is biased. So, and then you might be observing bias that your own measuring devices are introducing systematically. So this is one example where like just changing the name of a person, how much does that change the behavior of the model? And our work like was looking at, can we have a generic method for detecting such biases in models? This was a question we asked in a paper published at EMNLP in 2019 with my colleagues Ben Hutchinson and Margaret Mitchell. And the idea here is very simple. We use a target corpus and extract a small number of naturally occurring sentences from that corpus and identify what we call an anchor point. An anchor point is a point in that sentence where, or like a slot in that sentence where things that are semantically similar, such as names of people or names of products or names of technologies or names of places, etc., can be swapped in and out within that class, also called perturbed, right? And we can then run these set of perturbed sentences, perturbed naturally occurring sentences, through a classifier to see how much bias they have learned around these these concepts. And when I'm stressing the point about naturally occurring sentences, because up until that point in time, most of the fairness analysis in NLP looked at model behavior around a small set of like synthetically created sentences. Predominantly, that was the approach, whereas this was like looking at more naturally occurring sentences and providing a way to do that, or like providing a pipeline to do that. In this work, we use pronouns as a way to get an anchor point. Because with simple rules, we can replace a pronoun in a sentence with a name while keeping the syntactic structure of the sentence valid. And for other types of perturbations, you might want to find another way of getting an anchor point. For instance, if you want to perturb on place names, you might have to just like go with a set of place names as a starting point and then do perturbation. For names, we use pronouns, which was much easier than just like going with a set of names. So in terms of results, first, does perturbations result in switching toxicity labels at a chosen threshold? So at a threshold of 0.8, just by name perturbation, we found that around 35% of the sentences that were labeled as toxic flipped to being non-toxic. And almost a similar percentage of new sentences were flipped to being toxic just by changing a name. So this is like a significant problem if 35% of the sentences were going to actually change just by changing a name in that sentence. And this is not just something that was happening at the threshold of 0.8 for calling something to be non-toxic versus toxic. This was happening across board at various thresholds, various reasonable thresholds, I'd say, between 0.5 and 0.9. The percentage of flipping that happened here was more or less the same. And then in follow-up work, we asked, could this approach be used to detect biases around groups of people? And in follow-up work, which was published at ACL 2020, led by my colleague Ben Hutchinson, and joint work with my colleagues Emily Denton, Kelly Webster, Yu Zong, and Stephen Daniel. We looked at used this perturbation-based approaches to study social biases in NLP models around mentions of people with disabilities. Again, here we use the toxicity classification as the sort of like starting point. We also analyze sentiment analysis in the paper. I use the toxicity analysis for the slide deck here. So if the sentence that was given to the model was "I am a person" or "I am a tall person," these sentences do not have a high toxicity score. It's like 0.03, 0.08. If I say I'm a blind person or I'm a deaf person, the toxicity score goes up to 0.39 and 0.44, significantly higher. And if I say I'm a person with mental illness, the score goes even higher. This, again, could possibly be because these terms have negative connotations that might be what it has learned and is propagating here. Or it might be just that these terms are probably also used as abuses, like, people would just call each other, especially in social media, using disability names or disabilities as some sort of abuse might also be present in online spaces. For whatever reason, these biases do exist in data, and we also did a more statistical analysis of like how often or how strong these biases are. Right. So we applied the same perturbation sensitivity analysis here, but instead of names, we used mentions of people with disabilities. And rather than just going with an ad hoc set of mentions of disabilities, we curated a list of recommended and non-recommended ways to refer to people with disabilities based on various authoritative resources such as SIG Access, ADA National Network, and Anti-Defamation League. And we found that compared to the baseline, mentions of disability increase the chance of sentences being flagged as toxic, which significantly was the case across different types of disabilities as on the y-axis, as labeled on the y-axis. But one good thing or one positive thing in this finding was that often non-recommended referring expressions produced higher model scores, higher toxicity scores than recommended ones. So that's something that is positive here, that things that were, or like sentence or terms that were not recommended by these agencies did result, or the toxicity model has learned that association as well. But it still is the case that for many of the disabilities, just mention of the disability itself significantly increased the toxicity score to be higher. So that was about bias in predictions, right? Like, so we talked about like some of the biases in predictions. Now, let's look at biases in representation. So as I said, a lot of machine learning or NLP research in recent years use various meaning representations or word representations or word vector representations, like different terms is used for that, word embeddings, contextual embeddings. But in reality, these are like referring to things like pre-trained language models. Previously, it used to be word-to-vec and that kind of vector representations, but now it's more sophisticated models such as BERT, GPT-2, T5, and many others that are coming out like every year. So this work was done at a time when BERT was sort of like the BERT and various varieties of BERT was the state of the art at that time. So BERT is a pre-trained language model that is supposed to have learned sort of like the language representation or language model, so that when it is given a sentence with a slot to fill, the BERT model would come up with like what word to fill in that slot. So for this also, we use this perturbation kind of approach where we came up with like a set of template sentences, and we perturbed on the various different terms that can be used there, like so a deaf person, a person who is deaf, and these are different ways of referring to people with disabilities, and then having that sentence having like an open slot. So there were like a few dozen such templates, and they were perturbed for these different mentions of disabilities. And these sentences were then fed to the BERT model and then we analyzed the words that were generated by BERT as a way to sort of understand what kind of associations BERT has internally sort of made for these terms. And we then, to make a quantitative evaluation for this, we ran these words through a sentiment analyzer, for which the sentiment analyzer itself is an NLP model. So it has a tendency to have its own biases. So in order to sort of like neutralize that, we used a specific template, like a person is X kind of template, which is kind of neutralizes like any biases that it has on these words themselves, and use the sentiment analyzer that way to get like, and to analyze how often negative correlations are like learned by BERT or represented in BERT. It turns out that for many categories of disability, the frequency of negative association, so words with negative scores, negative valence, was higher than the baseline of like either not mentioning or not specifying disability. It's not the case with every single disability, and for some disabilities it was not that apparent, but as you can see, for many disabilities that was significantly higher, or the BERT was more likely to generate sentences or words with more or say, a negative valence. Now we asked, where could these biases be coming from? So the biases could be coming from various forms, and rest of the talk I'll be talking about these various sources. So the main idea is that the main arguments that most people make is that data out there is biased, and there will be a whole lot of like social stereotypes and social biases that are represented in data. So human biases that are captured in data could be influencing the models, right? Like through biased representations, as well as like through predictions, and reflecting through predictions. So first we looked at societal biases that are in source data, as in like where the text came from, right? For this, we looked at a subset we looked at a data set that was put together by Jigsaw, specifically to study biases around identity groups. So they had a subset of comments from their original sort of toxicity annotation data set that were labeled with a variety of identity attributes, including race, gender, I believe ethnicity, probably wrong, as well as mentions of disabilities. And a subset of these comments were labeled for mental illness, especially there were more than 5,000 sentences labeled with mentions of mental illness. And so we analyzed that subset for this study as a third part of the study, where we analyze that subset. And so, as I said, the corpus has been annotated with mentions of disability. We mine these annotations to uncover the words that were statistically significantly more collocated with mentions of mental illness. So we balanced it along like toxic versus not toxic, and as well as like sentences with mental illness and without mention of mental illness, and did a simple sort of log odds analysis with Dirichlet prior, a very simple but very powerful technique used in NLP social data language data analysis. We did that analysis, and perhaps unsurprisingly, we found that the mentions of mental health were more likely to co-occur with medical topics such as medicine, the first column. The first column has like things around like mental illness, health issues, disorder, and so on. The second column has more about like the treatments, help and care, diagnosis, therapy, counseling, and so on. But what was surprising to me, or we did go in with this expectation, was that a significant number of words that were statistically overrepresented in sentences with mental illness mentions were concepts such as homelessness, gun violence, and drug abuse. Once you see this association, once these words came up in our analysis, we are like, oh, this is totally makes sense, because homeless is any conversations around homelessness often evokes mental illness, as there is like a huge overlap. And whenever gun violence happens, like mental illness is one of the reasons that people usually discuss as like potential cause to like why a person engaged in gun violence. Similarly, drug abuse is another thing where mental illness and drug abuse have like a lot of topical overlap in public discourse. And these social associations are represented in this data, and that is probably where some of the negative associations are learned by the model. But societal biases is one. So this is where like the data has these biases, and like how do we fix them is a separate question that I do not get into this talk. But there are also other sources of biases. And this is next we looked at human biases in annotations. For this, this is an ongoing line of research that, sorry, there is fire. Sorry. So this is an ongoing line of research, and I will be talking about work that was published late last year and early this year, and led by my intern Aida Dawani, also at USC, and or finishing up at USC. I don't know if she has defended yet. So this is two papers. The first one is published at the Transactions of ACL and will be presented at ACL next month. Then there was a workshop paper at EMNLP last year. So here we are looking at how people disagree with one another, how annotators disagree with one another, and how taking majority vote, which is like the most common practice, is potentially a problem. So yeah, as I said, in a lot of data annotations form like one of the core sort of like task or core step in a lot of machine learning development. And often cases we collect data annotations through crowdsourced annotation platforms such as Amazon Mechanical Turk. We obtain annotations, or in those cases, we obtain annotations or labels from several different annotators on the same instance. Sometimes 3, sometimes 10, depending on how much money you have. Or I've seen even like much higher numbers. And most often, we aggregate them using majority vote, or just present an average score or distribution across these labels. And sometimes, if it is manageable, people do adjudication. So when people disagree, like, you go find them to like come to an agreement, or like find another expert annotator to sort of like resolve that disagreement and find that final answer. In all these approaches, we are or the researchers are chasing a single ground truth. So there is this expectation that for any given sentence, there is one single label. It's either toxic or non-toxic, right? Like in the case of toxicity, it's either positive, neutral, or negative in the case of sentiment analysis. So you come up with like a particular sort of like labeling scheme, and then you kind of like force that on the task. But in many of the subjective tasks, there may not be such a single ground truth, right? Things like hate speech or offensiveness or toxicity. What offends me may not be the same as like what offends you as a person. Like, and it is shaped by our socio-cultural backgrounds or lived experiences. Like if I've never experienced abuse online, I may see a particular kind of comment as like something as a joke and I can move on, whereas like someone else who has been abused multiple times on online platforms might take that very differently. And of course, there is a lot of studies that have demonstrated like how online abuse and things like that have very different rates at which it is propagated, or it is targeting different demographic groups, especially around gender, for instance, and religious groups also. So in this study, we started by asking first, does aggregated data uniformly capture all annotators' perspectives? Uh, for this, we analyzed 3 different data sets annotated for subjective tasks, around 8 different subjective concepts, 6 different emotions. These are emotion annotations for anger, disgust, fear, joy, sadness, and surprise. We also had an annotated data for sentiment from DS et al. And hate speech from Kennedy et al. That we analyzed. For some tasks, as marked in green circles in the bottom row, left and right, most annotators had pretty high agreement with the majority label. So here I'll do a little bit more on the chart. So here the y-axis shows the number of annotators who, sorry, x-axis shows the amount of agreement with the majority label, and y-axis shows the number of annotators who had that much agreement. So if you look at joy, annotations for joy and annotation for hate speech, most of the annotators had an agreement of like 0.6 to 0.8 with the majority label. In other words, like pretty high, moderate to high agreement with the majority label. So all annotators, most of the annotators like perspectives are like more or less uniformly represented. Whereas for some other tasks, like things like disgust and sentiment, a significant number of annotators had 0 to like very minimal agreement with the majority label. So what does that mean when the majority label does not capture, dozens of annotators that you have annotated? These are, human annotations, like, but like, what if like the majority label does not agree with a significant subsection of the humans that you hire to label your task? And one argument is that like these labelers were probably like noisy, they were not trustworthy, reliable annotators. But that's not the case, especially in the case of emotion annotations. It's the same annotator pool that had high agreement with the majority label for joy, but low agreement for something like disgust. In other words, like the actual task also matters, and different people have different perceptions on some of these concepts. Like disgust is probably something that has more variability than joy. So what does that mean when you actually hire like a few dozen annotators and like only a subset of that is like modeled in the majority vote? So that's one problem to address. We then looked at whether the aggregated data reflects certain social demographic groups' perspectives more than others. And for this, we analyzed the DS et al. Dataset, which had the demographic information in the dataset. Turns out that not all groups' perspectives were equally represented in the majority label. While there was no significant difference along the binary gender axis, the majority labels had significantly lower agreement with annotators who are identified as Black. Uh, and now this is a sort of disparity that is different from what is entirely in data. This is a disparity that is created by the machine learning researcher if they choose to do majority vote. This is a disparity created by the researchers or developers' choice of aggregating data using majority vote, right? Or treating Black annotators and Asian annotators and white annotators as interchangeable, not accounting for potential differences in perspectives that they bring to the annotation task. Um, I know that I don't have a lot of time, so I am going to go through the next part of the talk fairly quickly about what do we do. One of the ways that in our work, like we have looked at like how to do this, was using something called a multi-annotator modeling. This is like an ongoing work. The first part was published in Tackle, and which will be presented at ACL next month. So where we proposed a multi-task approach to predict individual annotators so that like their systematic differences are captured while keeping a shared representation of the task. So we investigated different sort of approaches towards multi-annotator models. The one on the left is the baseline approach, where it's basically no multi-annotator approach. Like it's just like a single task model. You take the majority vote up front, and then you train the model and just like predict the majority label. That's like the baseline approach and most common approach. Then we had these various 3 different multi-annotator models. I wouldn't go into the details of all of them, but on to the right is the multitask model, where there is a shared representation of the task, but there's also a shared part of the network that models each of the annotators separately. And then in the end, you can take a majority vote if you want to. What this enables us to do, besides being helpful to getting the final labels, what this enables us to do is to calculate the uncertainty in predictions as the variance of multiple annotators made, multiple annotations made for each instance. So you also at prediction time, you have a sense that is this a sentence that different annotators may have disagreed on? And that's an useful information in the prediction time so that like it could be appropriately routed to a human labeler, for instance. So we investigated the correlation of this uncertainty compared to some other kind of baseline approaches that uses like either the softmax prediction value or an approach called Monte Carlo approach using different dropout values for the model, for the network. So these are like other approaches towards like calculating certainty in predictions. And our multi-annotator models like had a significantly higher correlation with annotator disagreement, which is one significant advantage of this. And we also found that the uncertainty calculated that way has across different types. It models it varies across different types of erroneous predictions, such that on average, incorrect predictions of the multi-annotator model have higher uncertainty than correct predictions. Also, it gives you something more about the different types of errors. We found that the model is almost always certain about true negatives and uncertain about false positives. So this kind of insight is also helpful when you're launching this model into like production, when you're trying to do content moderation. Now the question was whether this hurt the predictive performance or time complexity. We compared the, if you just want to compare it with the majority prediction that like the baseline does, in this particular task, we obtained significantly higher accuracy. We do explain why that might be the case in the paper, but some other tasks like we obtained like more or less the same, slightly lower, but like significantly, not significantly different results. It also does not come with significant tax on the time per se. For training the single task baseline model, it took like 20.5 minutes in that particular setup, whereas this multitask model got only 22.3 minutes. So in closing, we talked about various ways biases can creep into the machine learning pipeline. And so far, I've only talked about data and model biases, human biases that are entering in the data and then propagating through the modeling process. But these biases also propagate through the deployment stages. And there are also other kinds of human biases that can enter in terms of modeling step, as well as in the problem formulation step itself, like how you define the problem. For instance, whether you define the terms toxicity in terms of a platform's perspective or marginalized communities perspective would shape what ML system like would be built then. And there's also human biases that could influence deployment, like setting the thresholds and like so on. And these biases, like over time, especially when ML systems are used to generate new content, new language, such as GPT-2 and 3 and so on, it may also have the potential to like create or like reinforce some of these biases. And this is a term like that Margaret Mitchell, my previous colleague, came up with, like called bias laundering. So we do have to find a way to model the societal context, accounting for its dynamically complex nature with feedback loops and delayed impacts and emergent properties. I have some work in that space. I won't go into the details of this, but I'm happy to chat about it like later if you're interested. But definitely do check out some work with my colleague, led by my colleague Donald Martin Jr., and with others, Jill Coburg, Andrew Smart, and William Isaac on participatory approaches to fairness using community-based system dynamics. So this is bringing together marginalized communities' perspectives in problem formulation. How can we do that? Drawing on some work in social science, in School of Social Work kind of disciplines. We also have work led by Nitya Sambashivan and my colleagues Erin Arneson, Ben Hutchinson, Tosi Doshi uh, on looking at how a lot of the fairness research, even the ones that I've talked about, is largely Western focused, situated in the Western context, aimed at like disparities in the Western context. So this is work where we sort of look at like which of those assumptions fall apart when you actually think about doing fairness work in other geocultural contexts and how to mitigate those issues. Just in closing, there is a crisis in AI around ethics, as you probably have heard about. This is not really a crisis in the public's understanding of science, but a crisis in science's understanding of the public. And a lot of our work, our team's work, also sort of tries to address this issue. Um, and with that, I will close. Sorry, we don't have a lot of time for questions, but I hope that there are questions.
Thank you, Vinod. Maybe we can all come off for a brief applause.
Thank you.
Yeah, please feel free to unmute, or if you don't feel comfortable, you can add any questions you might have into the chat. I think the timing was perfect. We have a half hour left for discussion.
Oh, I didn't realize that this was a 1.5 hour. Well, I should have realized, but.
I guess maybe I can start off. This is kind of maybe me being a bit of a newbie in the NLP space, right? But as you were discussing a lot of the results on toxicity, it sort of occurred to me that a lot of the problems are due to essentially the models are like learning these correlations between terms or whatever. But like, how much work are these models doing to actually capture the meaning of the sentences and actually understand, right? Like the example you had of like, the Gay and Lesbian Film Festival starts tomorrow, like is such a shocking example to me that like, we still don't have a model that can just understand that that is just a factual description of an event that is happening tomorrow. And the fact that, gay and lesbian happen to be in that sentence is going to trip up the toxicity model, so much.
Is that an observation or?
Well, I mean, I guess, yeah, maybe it's a high level comment. I mean, like how far off are we from really models that can understand like the semantic meaning of sentences rather than just sort of like these probabilistic correlations?
I think different people, I mean, people have very strong opinions on this. You probably know where my opinion stands. I think it is very, very far from like having reasoning capabilities. I think there's a lot of, unfortunately, there's a lot of hype around these technologies. I think in the last like 5-6 years, like deep learning has enabled deep learning powered with large amounts of like data and ability compute power has enabled us to do things that like previously was not doable, like using the kind of benchmark data sets that were already put in place for like measuring the quality of like progress, measuring the progress in this area. But I think so that technology is like advanced, like the ability to do a lot of these things using just simple correlations. It is not to say that like what it does is like not useful, but I don't see it as like having like any deeper understanding. It may have so much data about certain concepts that it might kind of spit out like predictions that are kind of like look meaningful, like it can generate text that look meaningful. So there's a lot of capabilities now it has, like these large language models and like the technologies that it has enabled has now that like than what was possible previously, but it is just far from it, like for concepts that are like have much less data from, and usually the examples that you see on like social media and all that, like cherry picked examples. Again, not to say that like it doesn't work for other cases, but so I think the kind of the example of like gay and lesbian film festival, I think that has since been fixed. Like, but like they found it, they fixed it, but like, what about like, I don't know if like what are the other unknowns about like the biases, unknown biases that are there that nobody's looking for. And this especially comes up in a lot of my work where I look at these cross-cultural differences or cross-cultural knowledge gaps when it comes to just AI in general and like fairness research in AI. So there's a lot of work on like gender bias and racial biases in like models. So these kind of like terms that like term lists that people have done used for a lot of this analysis. But if you think about other geocultural contexts, like what are the marginalized communities there, or what are the terms used to describe them, there's not even like any resources that are out there that you can use to do the evaluation. Like I now work on like some such research in the Indian context, and as a follow-up to the paper that I talked about in the end, and like in India, caste is a major discriminator, and there are no resources like in the US. Like you have this the name to racial association kind of like data sets that can be used to do such analysis. In India, such resources does not exist. Caste itself is like reification of caste itself is an illegal thing. So even studying that itself is a problematic thing. Like it's a very sensitive thing to do. So yeah, there's a lot of challenges like about like understanding disparities that we don't know exist in these models. So yeah, there's a long way to go in terms of like language understanding, but it in terms of like making these models to do certain things, I think we have come a long way from like the last 5 years, 5 6 years.
Uh, uh, Very interesting talk. I have a question. So, I think jumping off of the previous question, what do you think are like more, like straightforward ways to mitigate these kinds of issues? Like something that is doable in the next few, like couple of years or something. Because as you mentioned, there's a long way to go, but there are some steps that we can take to mitigate these, right? So, yeah, what do you recommend doing to mitigate this?
So there is a lot of research on bias mitigation related efforts. I personally do not work a lot on mitigation because mitigation sometimes can be like a false assurance. So I work a lot more on evaluating these issues. Like evaluation is like where I focus a lot of my energy on. So in terms of mitigation, like some simple things like about I think people have come up with like mitigation approaches that tackle these issues in the data stage, where you do some sort of like data augmentation, data perturbations, data balancing, all sorts of like data manipulation efforts to, and has shown like really good effects in terms of like mitigating biases around the terms that, or like the terms that you're found biases around. And sometimes the mitigations are like really, I mean, and there are also like super fancy modeling techniques to do mitigation more effectively as well. There are like adversarial training for fairness. There's like papers that have done that, but often cases like simple data manipulation techniques like seem to have worked more or less well. And for instance, like the biases that I talked about like names, persons' names,
Mhm.
right? The mitigation was like simply just like removing names in sentences, right? Like it's easy to do. Like it's not as trivial to do it, but as long as you have so when we in that paper, we also talk about Google's cloud. Sentiment model also had that same issue, and Google Cloud, I think, has since put a mitigation out there where they have removed, I think there's like some sort of like a filter that removes sentence or like names from sentences before running through. So I don't know exactly what the fix is. Um, so so some of the mitigations are like really simple, and there are fancy sort of like modeling approaches that kind of like takes into account like some of these fairness objectives in the training process itself, which can be good if you're interested in that kind of work. But like I think data mitigation or like data balancing could also work. But
Okay.
the bigger point I want to make is that many times these kind of mitigations like can be patchworky, and which is totally
Yeah.
fine. Sometimes have to do patchwork, but it gives you a false sense of like, oh, we have now a unbiased model. Like, and one paper that particularly that pointed out that was 2019. There was a paper on called "Lipstick on a Pig" paper. Basically, it showed that like many of the debiased models, like models that like previously said that, oh, we found gender bias and now we have this mitigation that debiased it. The this lipstick on a pig paper said that like, no, you didn't debias it. It's just like you just like put a lipstick on a pig because like the model underlying association still exists in the model, and like these biases still exist in the model. You just like won't be able to measure them using the approach that you use to measure the bias. And um, it's another analogy that I often use is like some of these mitigations you can think of. Again, you need to mitigate it, like if, especially if you're in like a product space, you're actually putting these products out in the world. You need to like fix these issues, but knowing that it doesn't really fix the underlying issue. Like the analogy that I use is like the canary in a coal mine situation. So you have this like bird that you go into coal mines with, like as so that the bird would die if there is poisonous gases in the coal mine, like the bird would die so that the miners would know, okay, fine, there is poisonous gas, you get out of there. So here what we are basically doing is we are killing the bird. If the bird is like see, these kind of like word level biases or the biases around names and all that, like I think of them as like the bird, like it is basically telling something about underlying biases, and if I just like mask them, it doesn't remove the underlying biases. It just like it's not like it doesn't reveal it to me anymore. So I'll stop here. I've been talking for too long. Sorry.
No, that is great. Thank you so much. That answered my question. Thank you.
I think actually Rose, who unfortunately had to hop off, so maybe won't get to hear the answer to her question, but had a great question in the chat. That's a good follow-up to that, was how can we use these research results to create technology that improve these situations? So, I mean, my interpretation of that is to your point of like the AI models that are uncovering some of these biases in the data are, the sort of canaries, and by just covering them up, we're not actually removing the biases from society. So how can we think about, using these really powerful computational tools we're building to actually improve conditions in the world, which is, I think, what a lot of us here are actually really interested in.
Great question. I mean, I also have, before coming to Google, like I used to like think about ways like socially beneficial applications for NLP and like machine learning and stuff like that. So I think it resonates with me. But I also, before I start like answering that, like I do want to say that like sometimes you don't need NLP to save the world. Like, just because we know NLP, we don't necessarily, maybe NLP isn't the answer for some of these. I mean, there may be ways in which like we can contribute to it, but like I think NLP may not be able to solve racism in society. Like, but it could help like unearth or reveal things. And so one thing in that respect is I think these tools could be used as like powerful sort of like analytical tools rather than predictive systems, right? Like, so predictive systems, when you're using these like models as like predictive systems is like when you're basically their biases are a problem, whereas like when you're actually using these as analytical tools, like these are powerful measurement tools of biases in society. So if you train like such a model, like such a large model along across data from a particular context, then it can reveal something about that social context, reveal social disparities. So I've seen like time and time again, like some such associations like that these models reveal that kind of capture various social stereotypes that that are reflected in social data that's out there. So that's one way that it doesn't fix the issue, but at least like it would bring up some of these issues. Sabyasachi. Wait. I think Sabyasachi has a question.
Sally, I can't hear you if you're speaking.
Can you hear me now?
Yeah.
Yes.
Yes. Yeah. So first of all, thank you for the talk. It was really great. So I have two questions about the different kinds of biases that you talked about in the presentation.
Mm-hmm.
So you talked about the biases in the source data and the bias in the annotation. So for the first bias, do you think that we should like move away from the MLM objective, like math language modeling objective, because that is inherently assuming that the meaning of a word depends upon its context, whereas that might not be the case for all sentences. So do you think that we should like move away from that trading objective? And the second question that I had for the annotation bias that you talked about. So like, what is the final objective? Like, do you think we should like predict a label for each annotator individually, or like a group of annotators individually, depending upon their, let's say, demographic similarities? So those are the two questions that I have.
I mean, those are fantastic questions. Also, like, I can talk about it for an entire day. The first question, so I think maybe I'll just like restate the question in terms of like, it's not just about mass language models, like just in general, like these like pre-trained large language models that learn representations or learn the ability to come up with representations of like language based on prior language that's out there. I mean, the BERT models that I talked about is like kind of outdated now. There's like other contextual language models now, but the question probably applies to them as well. So I don't think like again, this is like, I don't want to prescribe like one solution or one approach necessarily, because this is like an area for debate. I think I think they are useful modeling approaches. They have a lot of ability to, as I said, like to enable a lot of other downstream technologies. But I think being more, aware of these issues of like, so I think one pet peeve I have is like calling them meaning representations. I know that like I use the term because I wanted to like talk about how the community use the term. I think when you think about it as meaning, that there is like this vector representation of like a meaning of a word. That's where like I think like a big leap it is. If you just call it like a co-occurrence matrix, I'm totally fine with that. It is a co-occurrence matrix from like a large data set. That's similar to like if you have a spreadsheet with like 200 rows and you just like create like a co-occurrence matrix or correlation matrix or something. Like that's an insightful analysis to do, and like that input would be useful for any downstream analysis. That's an important analysis, right? Like, so what many of these like word or like language representation language models do is kind of like having a more sophisticated way of like capturing co-occurrence metrics of like various words, and that is useful for like any language processing downstream. So in that context, like I really think it is useful. But I think oftentimes the ability for these models to like generate new language or fill in sentences, fill in like, you know, given a prompt, that kind of fascinates people. So people kind of ascribe a lot more ability there, as like, okay, this is going to just like create language there, and that's some useful thing. Sure, it creates like legible looking language, but it depends on the prompt that you're giving them. Like if you prompt the model with like something really innocuous, even if the data had like some really bad associations, the model is going to spit out like really terrible things about that people or that set of people. I don't want to use examples here because some of the published work, I mean, there's like a lot of conversation online about like if you probe like one of these models with like certain religious names and stuff, it just like starts spewing out like really terrible things. So it's not like as long as if you see that as like, oh, that's a correlation or that's a co-occurrence in this data, that's totally a fine thing. But when you say that like, oh, I have a model now that it can talk like humans, that's where the problem, it kind of like falls, that context collapse happens. So it's a bit of a hand wavy answer, because I personally don't think like we should move away from it, but rather we should take it for what it is and use it very carefully when using it in like downstream applications, and also test for these associations that you actually want to account for in downstream applications, because knowing that this is not magic, this is just math. This is co-occurrence metrics on like words. And so when you're using these models in downstream applications, like testing for these biases around like as many axes that are relevant is important. The second question was, your question was about like, does that answer the first question before I move on to the second one?
Yes, it does. Thank you for that.
The second one was about annotations and annotation. Should we create like separate models for each individual annotator or groups of annotators? So even though the paper that we have published at like Tackle, we do multi-annotator modeling, the idea was not necessarily to like have separate models for like annotators, because annotators are like just like part of like the development process, like, you know, one annotator versus another annotator, like in the downstream application, like it doesn't really make sense to say like, oh, this is from annotator 37, like do you want the annotator 37's annotations or like 28's annotation? Like that doesn't make any sense. However, I think such a modeling can still be useful when you group annotators based on certain characteristics that are probably important. So my way of thinking at it is that um, uh, it is such an analysis first could inform us like whether a particular task has variance around or like variation around like certain axes. Say if, say, sentiment analysis, there's no difference, or say, let's say hate speech analysis, let's say there's no difference between like people who identify as male versus female or non-binary, then it doesn't make, you know, you don't need to like create like separate models. But if you say, if you find that you build a hate speech model and annotators from India have significantly different perspectives on what is considered offensive or hate speech from annotators in Middle East, from annotators from Russia versus annotators from US, then it may, you as a platform may want to ask, if you have a product or a platform that is rolled out in all these countries, do you want to have a machine learning model that actually abides by the values of that, normative values of that society, as long as annotators represent that normative values, as that itself is a big leap. That's a design choice, that a decision that like the platform can make, but that ability doesn't exist currently. People sometimes like they create like separate, like completely separate models, but that is not really scalable. Whereas like here in a multitask approach, like you have an ability to like have a common shared understanding of the task, but having more contextualized or disaggregated modeling, what I start to call it as disaggregated modeling, that caters to specific like normative value systems, like when it comes to subjective tasks. So that can be beneficial. And it may also be something that like the platform does not want to do. For instance, like a platform can decide like, we are a free speech platform, we would not do any content moderation, they can remove all content moderation. Or a platform can decide like, we are a platform based out of like Silicon Valley in the US, and we have a particular value system that we adhere to, and that is what like would be allowed in our platform. So even if like say in the Middle East, in Saudi Arabia, people may have a different value system, this platform can decide like, that doesn't matter, like we follow our value system. So in which case like they can just like use like one model, right? Like, so it depends on like the context, but the ability to do this disaggregated modeling is regardless a good evaluation tool, like to understand like when there are disagreements, and if you want to account for like this valid disagreements between human annotators. Does that answer your question?
Yes, it does. Yeah. Thank you for that.
Sure.
Sort of following up on that, I'm wondering, have you guys thought at all about, I mean, you talked about sort of like grouping the annotators, right? But instead of like, you know, by doing it by sort of like predetermined kind of attributes, like demographic attributes or locations, just kind of like clustering based on sort of the similarity of their responses to the question. I mean, because I mean, I'm thinking of this as really important kind of work in these subjective tasks, right? And you know, even though I might be from exactly the same place as another person and look similar to them, I might have a very different sort of belief system or way of like, you know, responding to these subjective questions. So I'm wondering if there's thought of work into sort of just kind of automatically figuring out what those important groupings would be.
Yes, great question. And actually, that was one of the first follow-up work that we did, was to cluster annotators. I forget exactly. I mean, so that work is not completed yet, but there were some clusters that were identified, like, you know, annotators were grouped together with certain clusters. And if I remember correctly, there was also like some overlap with like some social demographic variables and like clusters, but it wasn't like such a clean picture as one could imagine, like doing that analysis like this in the past. So that work is still ongoing. We don't have it published. So we have also some ongoing work where we are looking. So we look at like these different, you know, geocultural like background of people, like people coming from like Western Europe, Eastern Europe, like Sub-Saharan Africa, East Asia, South Asia, and so on. But we also have those annotators like do something called like the moral foundations questionnaire, which with colleagues at USC, like USC has like a lot of research in social psychology on that, and to understand, like have a kind of slightly more nuanced understanding of like when people disagree, like if it is like more because of like their cultural, sorry, their moral values are different, like, you know, when it comes to like annotations of offensiveness, is that derived, or is that any association that we find in the data, is that mediated through the moral foundations? And there might be different regions may have different leanings in terms of like moral, and it is already demonstrated. So we have work on sort of like capturing some such like clusters that are more nuanced rather than like these social categories of like that are about protected categories or marginalized categories, because that is not necessarily like so basically trying to find ways to like model the annotators around categories that are like probably meaningful for the task, rather than like just like some social categories that we impose on them. But I don't have like results to talk about right now.
So we know that, again, thank you for a wonderful talk. One,
Thank you.
yeah, curious question I had, right, related like to what Chris just asked, is so when we have a task like an annotation task as a proxy to sort of probe people's sort of perception and judgment more than just perception, sort of your sort of it is in a way it is a contrived task in many ways, right, to categorize or ask people about their subjective opinion. Are there cases where we can implicitly kind of get at how perceptions sort of modulate or mediate people's action and behavior, and and how they may relate to specific characterizations of people that we think have these sort of biased or forms, or is just diversity in how individuals view and experience information or other sort of act upon data. Because it's a fine line, right? There's clear cases where we can say, well, this is based on current societal norms or whatever foundational things, that this seems like okay, not typical. But in other cases, it's just natural variability across individuals or even groups of individuals that may experience. So there's two parts. One is this kind of can we get at more ecologically valid ways of characterizing human perception and action beyond these annotation type tasks that we've been using, right? Because that we could formalize an experiment, we can do all these things, but to complement that, can we do something better? Have you thought about sort of ways that you would do?
Yeah, if I understand correctly, like, so say if in the annotations may capture, like, it's a contrived way of asking, like, if this person has like or it's about annotation about hate speech or something, and then later when you analyze it, like, find out that okay, this person or this set of people find like or like it's a find particular mentions of like certain groups or like negative things about certain groups are like considered as less offensive or something, but that may not be how they act in reality in society. So I have one response to this is like, I think it comes from like the goal of that study, right? Like, so I think in the past, before coming to Google, when I was doing more computational social psychology kind of like work, I wanted to understand like whether the person have like biases and like how they engage in society, and like it's making a call about like social biases and that impact on society in that way, right? Like, that okay, there is this like in the work at Stanford, like that we had about like racial biases and like disparities in police community interactions and all that. Like there's a lot of that work is like motivated from like establishing that there exists like some, or looking if there is exists some biases and like what impact it has on society or experiences of people. But in this case, like in this particular study, I think I would basically say that like in this context, their action is their annotation, right? Like I think I think like they are not being studied as like, I think it's less about like how they go out in the society and like how they behave with like a particular individual of a particular social group, but like in the context of like whether the data set is the construct, like data set is the construct that we are studying, like whether that has captured that represents a particular biased view, as I think it might be possibly from like the annotator's biases, or it could be just like a random disagreement, and like that's like a more, it's a different question there than like whether they actually have like that action in the society. Does that answer the question? I don't know if I misunderstood the question.
Yeah, generally, yeah, it's just an open
You're muted.
thought that I've had
no.
About this whole business of how we can translate this sort of, when we kind of define an annotation task by itself, we are kind of prescribing, so what is that we want to look for, and then we want to probe like how would people respond to it. But not for all cases, but and some of the kinds of questions of social cultural sort of import, like we're asking, right, about people or and their actions. other implicit ways of sort of by just
Yeah.
natural experiment type of a thing that will
Yeah.
complement these more well-designed annotation tasks.
Yeah, got it.
Yeah.
I think this is keep on coming up, especially when we get what we call annotations for various social things. Like I think recently we were collecting some data on social stereotypes, and like going and asking like, hey, is this a social stereotype? Sure, you can ask that question and they will do something, they will give you an answer, but that's not the way social psychologists like measure social stereotypes.
Exactly.
There's like an implicit way of measuring like whether something is a social. So that's where like whether it's like an expressed thing versus like an what they have internalized, like, and
Exactly.
that's a question for both models and data. So when we evaluate, there's a lot of like people work on like machine learning models have this social stereotype, but in essence it's basically just that like it's spitting out when it's asked like, hey, what do you think about this group of people, and then the model is spitting out like something really stereotypical. It's basically the expressed opinion of the model, expressed like text of the model. Like it doesn't mean that like that same association is like driving the predictions that the model is making like down the straight. So I think it's in the model, in the people also, you can ask them like, hey, is this a stereotype, versus like you having them do something like an IAT test or something. It's like very different like things that you're measuring.
Thank you.
Well, I think we're at time, so let's all come off mute and give Vinod one more round of applause. Thank you, Vinod.
Thank you so much. Thanks so much for all the wonderful questions, and I really enjoyed that.
And Shri, do you want to say a couple words to wrap up this series? Thank you so much for hosting this at USC this semester.
Thank you so much, everyone, our colleagues at Google, Tomo, and the whole media understanding and social exploration team, and the CCMI group at USC for jointly hosting the series. We're looking forward to a new series this fall, and with another exciting lineup of talks. Thanks once again, and I think this is the last talk, so you kind of closed up really nicely. A lot of food for thought for all of us to work on. And thank you so much, and thanks so much for to Kathy for helping organize and advertise and and being on top of everything. Thank you so much, Kathy, also for successful semester of CCMI talks. Thank you.
Thanks, Kathy.
Yeah, thank you.
Without her. All right. Well, thank you all. Have a wonderful rest of your day, and hopefully we'll see everyone in the fall.
Yep.
Yeah. See you then. Bye.
Bye.
Bye.